All right, this is the video for Wednesday, the 22nd of April. Hope everyone's doing well. We've only got a little while to go, so I hope that you're sticking with it. Now, we've been working this week on radicals, simplifying radicals, graphing radicals, working with radicals, and of course a radical would be like a square root or a cubic root or a fourth root, something like that. Yesterday's assignment I still have on the board. I have a number of you who turned in worksheets, so I know that you've been on the video. That's the only way that you could have gotten the assignment, was to get on the video and watch. However, most of you seem to really struggle, despite the fact that I gave a worksheet that had step-by-step instructions and things such as that. So we're going to go over today's assignment. I'm going to review it. I'm going to give the answers to it. I'm going to go through it step by step. I don't think I've got time to go through all 5, but I'll pick a couple interesting ones here. And then we're going to do the exact same thing tomorrow as well. I feel like you all can certainly do this, and we're gonna figure it out. Okay, so I'm getting ready to erase all but the first one, but I'm going to give it just a moment. You can pause the video if you missed yesterday's assignment. You need to make it up. I'm just going to give just a moment before I erase. You can pause the video and write them down. All right, so let's look at number 1. Number 1. We are to according to the instructions, we're to solve for x and y and graph. So again, these functions are a relationship between x and y. There's no mystery to what a function is. A function just means that the identity of x, because it's in the equation, tells you what y is going to be over and over and over again. Okay. Now, ever since you were first introduced to x and y, if you could, plug in a value for x, y is going to pop out. But the point of a function is that you get the privilege of choosing your x, right? And then it's either going to be, well, that doesn't exist, or it's going to give you a series of ordered pairs, XY pairs, that you can put dots on a graph, and then you can, there you go, you can connect the dots, and it tells you what that relationship is. So the first thing we're going to do is we're going to choose some x's. Now with radicals, we have square roots. Now it could be cubic roots or fourth roots, but this is Algebra I, so we're going to stick with square roots. So I need something that is easily made a square root. I'm going to think ahead. I'm going to make life easy for myself, because that's what smart people do. Now, if you choose a number that's not a perfect square and you have to use your calculator to find the square root, round it to the nearest tenth and go from there. Okay? Because remember, in our graphs, whole numbers tend to be pretty small. Anything smaller than a tenth you're not going to be able to distinguish that on the graphs, the graph paper we use in high school math anyway. But I'm going to use numbers that are going to be perfect squares. I'm going to do this on purpose, and I'm probably going to use the same numbers over and over again. I'll show you how that works. So the first thing I'm going to realize is that when I see this f of x or g of x or s of x or whatever else of x that it is, I'm going to think of that merely as y. That's all. Nothing confusing, nothing to lose your confidence about. You just replace f of x with y in your mind, and there you go. Now I need to come up with a series of numbers, and I have to figure out what that number is going to be. So I'm going to come up with a table. This is what my table is going to look like. I'm going to drop in a series of x's, and the y, I'm going to pick a number here for x. I'm going to put it into my equation up here, and I'm going to see what y turns out to be. Okay. So let's say I'm going to go with 0 because it's a perfect square. I'm going to go with 1 because it's a perfect square. I'm going to go with 4 and 9 because they're all perfect squares. Do I have to go with those numbers? Nope. You choose whatever you want, but my way's easy, so do it my way. All right. So now I'm going to come up here to this equation, and I'm going to work it through this way. I'm going to say y equals the square root of 0 plus 1. Well, y equals 0 plus 1, y equals 1. All right? So when x equals 0, y equals 1. When x equals 0, y equals 1. All right? Well, what happens when x equals 1? Our equation is y is the square root of x plus 1, or the square root of 1 plus 1. What's the square root of 1? It's 1, so 2. Okay, not hard at all. I'm going to drop in a 4. Y equals the square root of 4 plus 1. That's 2 plus 1. That's 3. Okay, and y equals the square root of x plus 1, I'm going to drop in a 9, 4. All right, I have filled out my chart. Now, I promise you, and I'm trying to keep a good attitude here, I promise you I could take this math down to the 7th grade and they could do this math. So if you didn't get this last night, you weren't watching the video, you weren't following the directions on the worksheet, okay? This is not hard stuff. You can do it. Just pick an x, put it in there, and solve. You know what a square root is, and you certainly know what plus 1 is, okay? So, now that I've got this information, now I'm going to graph. This is an x-axis, this is a y-axis, okay? This is 0, 0, and I'm just going to go, because I need all the way out to x equals 9. 1, 2, 3, 4, 5, 6, 7, 8. There's 9 right there. And I need as far as y equals 1, 2, 3, 4. So there you go. There's 4. All right. So notice that when I'm graphing radicals, so far we aren't using a whole lot of negative x. Okay. That's something we should pick up on. That's a repeated characteristic. In fact, none of your graphs from yesterday should have had a negative x going over there. All right, so here's what I'm going to do. These are my ordered pairs, okay? So when x equals 0, y equals 1. So I'm going to put a little dot here. I'm going to go ahead, let's label this A, B, C, and D, just so you all can keep up. There's A, all right? X is 0, y is 1. Let's find dot B. When x is 1, y is 2. That's B. When x is 4, 1, 2, 3, 4, y is 3. And when x is 9, y is 4. So the graph of a radical looks something like, I don't know, half of a bullet. There you have it. That's the graph for number 1. All right, let's do number 2. The formula for number 2 was x, the square root of x minus 2. So y equals the square root of x minus 2. Again, x, y. Now notice here that my radical is x minus 2. So you know what I'm going to do? Because I'm smart, right? I'm going to use the same numbers that I used last time. I'm going to inflate them a little bit. I'm going to inflate them by 2. That way my value for x actually comes out to be what I'm looking for here. All right. So in other words, let me show you what I'm talking. I'm just going to pick random x's, but in my mind they're not so random because I want numbers that are easy to deal with math. I'm going to say for my first x, I'm going to say I want it to be 2. Okay, watch what I'm doing. The next one I want to be 6. No, let's do this. The next one I want to be 3, then 6, then 11. Okay. So why did you choose those numbers? Well, let's plug them into our equation and see what happens. Y equals the square root of x minus 2. Okay, I'm going to say that x equals 2. So y equals the square root of 0, y equals 0. When x equals 2, y equals 0. Looks like I'm onto something here. I'm going to say that x equals 3. So I'm going to plug in 3 for my x. So therefore y equals the square root of 3 minus 2, or the square root of 1, or y equals 1. All right, for the next one, I'm going to choose the number 6. You see why I chose these numbers? Because if you subtract 2 from them, they become that nice, easy, perfect square that I dealt with in the first problem. And all I had to do was know how to subtract 2 from a number. You can do it. All right, 6 minus 2, 4, 2. All right, so when x is 6, y is 2. When x equals 11, our equation becomes y equals the square root of 11 minus 2, which is the square root of 9, which is 3 here. All right. Once again. All right. Now, little hint here, little pro tip. I'm drawing my graph. I see what my numbers are. My largest y is 3, my largest x is 11. I don't have any negative numbers on this graph, so I'm really not going to use up a lot of my paper for the negatives. Just a little pro tip there. All right, but I do need x to go all the way out to 11. There's 11, and I need y to go up to as far as 3. All right, so here are my ordered pairs. And of course, this is y, this is x. When x equals 2, y equals 0. We'll call that point A. All right, did you see I did that? My x on my x-axis, my y on my y-axis. When x equals 2, y equals 0. When x equals 3, y equals 1. When x equals 6, there's 2, 4, 6, y equals 2. And when x equals 11, y equals 3. And I have my half bullet shape again. Notice that it doesn't start at the origin. It starts at x equals 2, y equals 0. And that's because, obviously, we had something going on there, right, that affected our graph. Let's drop down and do, let's just do tell you what, let's go ahead and do number 5. I think that would be a good one. It kind of puts together several of the aspects of the others anyway. All right. So number 5, the function of x is negative 2 times the square root of x minus 1. Negative 2 times the square root of x minus 1. All right, I'm going to draw my table once again. All right, so by now you know my trick. I'm going to think about how to get to those nice, perfect, round, even, perfect squares, and I'm going to keep doing that, okay? Because life is easy when you make it easy. So for my first x, it's going to be, anybody know what it's going to be? I'll bet you do. If you're thinking about it, it's going to be 1. Why? Because I'm going to put a 1 here, and 1 minus 1 is going to be 0, and that's my first starting point, just like that, okay? So I'm going to say 1, okay? My next one is going to be 2. Bet you know why by now, don't you? The next one is going to be 5. And my next one is going to be 10. Do you have to have these values of x? No, but life's a lot harder on you if you don't do it the way that I'm showing you. I like these nice, neat, even numbers, and as you can tell, when I graph them, I can see what the function's graph is perfectly with just these 4 numbers. All right, so now it's time to plug these in. Y equals negative 2 times the square root of x minus 1. Y equals negative 2 times the square root of x. Well, let's put my 1 in here, minus 1. In other words, y equals negative 2 times the square root of 0. Y equals negative 2 times 0. Y equals 0. Therefore, when x equals 1, y equals 0. By now, this should not be a surprise to you. All right. Well, x equals 2. Drop it in here. Y equals negative 2 times the square root of 2 minus 1. Square root of 2 minus 1 is the same thing as square root of 1. Square root of 1 is 1. So y equals negative 2. Oh, this is the first time we've had a negative number. I wonder why. It's because we're multiplying our radical by a negative number. In other words, we're getting ready to see the other half of that bullet, the kind that goes down instead of up and over. All right, so when x equals 2, y equals negative 2. What happens when x equals 5? Let's find out. Y equals negative 2 times the square root of 5 minus 1. In other words, y equals negative 2 times the square root of 4. In other words, y equals negative 2 times 2, negative 4. So when x equals 5, y equals negative 4. (10). What happens when x equals 10? Let's plug it in and see. Y equals negative 2 times the square root of 10 minus 1. Y equals negative 2 times the square root of 9. Y equals negative 2 times 3. Negative 6. All right. So there's my graph. My table. Now let's make it in graph form. Okay, so I need my my y and my x. Notice I didn't draw much as far as positive y is concerned because I don't have any positive y's. And I need x going all the way out to 10, so let's go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10. I need y going as far as negative 1, negative 2, negative 3, negative 4, negative 5, negative 6. There's negative 6 right there. Okay, so here are my ordered pairs. When x equals 1, y equals 0. When x equals 2, y equals negative 2. When x equals 5, 2, 4, 5, y equals negative 4. About right there. And when x equals 10, y equals negative 6, which is down here. And these are points C and D. Here's my graph. All right, so anyhow, that's those are the worksheet problems with answers from yesterday. Today's worksheet is very similar. A little encouragement to you. Listen, I know this is unusual. Some of you, I'm sure it's been a month and a half now since we were at school, or getting close to it. It's longer than a month, at least a month and a week and a half or so. It's getting close onto that, and I'm sure that you've filled your lives with other things. You're doing things. Maybe some of you have taken jobs with family members, or you're I don't know. Maybe your brain's just on summer break. But don't fall behind here, okay? Your habits. If we end up with a 4.5 month break where your brain is not in use at all, that's going to be very hard to come back from in August. So we need you working hard, okay? You need to be faithful and accountable to this. Let's not make excuses. You need to do your homework every day. So anyhow, I'm going to be talking to families tomorrow, families that I've not heard from, students for a little while. I just need to see that work coming in. If you need help, call me, text me, talk to me, okay? I'm your math teacher. I will help you through this in any way that I can. But I can't help you if you don't do the work and if you don't reach out, okay? It's that simple. If you'll reach out, I'll help you. If you're not asking for help, I just assume that you didn't do your work, okay? Don't do that.